we're jumping in straight into session 3, which is going to be a little bit more of a hands-on session in which we're going to cover image navigation. So the objectives for this session are to learn how to load anatomical and segmentation images into ITK-SNAP using the menu, and also we can play with some other ways of loading images. We're going to learn how to change the visual appearance of anatomical images by adjusting contrast and changing color maps. And we're also going to adjust image orientation when the image header includes incorrect information, if we get to that. So we're actually going to cover quickly quite a few operations. So loading images, 3D image cursor, zoom and pan, contrast adjustment, color maps, loading segmentations, adjusting opacity, and measuring volumes. So we covered quite a few things in this session. This is the image I/O wizard. You'll have an exercise towards the end of this that demonstrates this. So this kind of dialog you'll use a lot when you're interacting with ITK-SNAP, and it has a browse button which brings up the system file selection dialog, but it also has a very useful history button which shows you all the recent images that you have loaded. So this is a good way, once you've worked with an image, to bring it back quickly. Once you've selected an image, there's a file format box where it tries to guess the file format from the image file name. Sometimes it's right, sometimes you have to correct it. So sometimes your image file extension is not informative enough to guess what is the file format, so you might have to override the image file format. But the sequence is click Browse, get a file name in here, check that the file format is correct, and then go to the next page. And we'll practice with this as well. And actually, here comes a live demo of that concept. So here I'm bringing up ITK-SNAP, and I'm going to say Open Image, so I can select it from this button over here, or I can go to File, Open Image. Here's my little dialog. I'm going to hit Browse, go to my desktop, go to my training materials, go to this session, data, just pick random folder, and here I've got my file name, and this guessed correctly from the extension that this is a NIFTI format image. So I'm going to hit Next, and my image gets loaded, and I see a little bit of the metadata from the image listed here. So the image dimensions, voxel spacing, stuff like that. Other ways in which I can load images are through drag and drop. So I can go in the file system and find my data and just drag the image over, and it's going to load. If I load another image over, it actually asks me what I want to do with that image. So I can load it as a main image, or I could load it as an overlay. So there are a few options here. And sometimes even double clicking works. Sometimes it doesn't. It kind of varies by operating system version. So this is the main image window, and we're just going to go through the different components of it. So these black background squares, these are the 3 orthogonal views, or slice views. So these are three cuts through the 3-dimensional image volume. In the left bottom corner is this 3-dimensional view in which you can view 3-dimensional surface renderings of the segmentation. And on the left is a toolbox. Well, we'll call this whole thing a control panel, this whole vertical part of the user interface is a control panel, and it's organized into a main toolbox at the top left corner. So this main toolbox is where you select different tools, like for navigation, for zooming, for drawing on top of the image, etc. Underneath is a panel of different inspectors. So these different inspectors sort of provide additional information and additional controls grouped sort of in a logical way. And we'll look at these inspectors. So it's kind of, what these inspectors do is prevent us from having to put 100 different boxes and controls and check boxes on the same window. That's in the old days, ITK-SNAP had lots and lots of controls all there on the left, and now we've sort of organized them into these inspectors, which makes it a little bit cleaner, but also means sometimes you have to do an extra click to bring up the right inspector. At the very bottom is a 3D toolbox, and these are tools for interacting with this three-dimensional visualization. So you might want to rotate it, or you might want to click on a point in it, or you can even spray paint it. And so these are different tools that you can select for 3D interaction. And finally, not seen here, but there's the menu where you can access all kinds of controls and open up additional dialogues. So the first thing we're going to talk about is the ITK-SNAP cursor. So these orange dotted crosshairs that you see in these three orthogonal slices, we call them the 3D cursor. And the 3D cursor basically represents the point or voxel in the image where these three orthogonal slices intersect. There's a three-dimensional image through which we're slicing in three orthogonal planes, and there's always one point where these three slices all intersect. And that point is represented by this orange cursor. By navigation I mean going through the image, viewing different aspects of image. So navigation is really about visualizing the image, finding the location and the view of the image that you're most interested in for your particular task. And the modes of navigation include repositioning of this three-dimensional cursor, which you can do both out of plane and in plane, and I'll show you what I mean by that. Zooming in, so being able to see a detail of the image in greater detail, and then panning around. So we'll see all of these navigation modes. As we go through the navigation modes, we're going to see this kind of setup in the slides. On the left, we see a representation of a image in three-dimensional space. And I don't know how easy it is to see here, but there are three orthogonal planes. Two of them are very, very subtle, and the third one is shown more clearly. And then the corresponding view in ITK-SNAP, where you see this slice corresponds to this slice, and then these two slices correspond to these two slices that are harder to see here. And so I'm going to show what different navigation modes look like in ITK-SNAP. And on the left, you're going to see the corresponding navigation in a three-dimensional space, just to better understand how moving the cursor around in ITK-SNAP relates to the repositioning of these three slice planes in a three-dimensional space. So we're going to be interacting with this slice here. So as if we're clicking in this slice and we're not touching the other two slices for this demonstration. So the first kind of navigation mode is out of plane. And what that means is that we're moving this slice plane along its axis. You can see what it's doing, right? In a three-dimensional space, you see the slide going back and forth. And what you can see here that the image is changing. In these orthogonal views, you can see that the cursor is moving. So in order to perform this kind of out-of-slice navigation, you can change this slider over here, or you can change the cursor in the other two planes, and you will also get the same kind of motion. So the other kind of navigation is in plane, and that means the slice that we're interacting with is staying intact, but the cursor is changing relative to the slice, which means that the other two slice views are being changed. You see? So this slice is being fixed. We're repositioning the cursor in this slice, and as we're doing this, we're slicing the three-dimensional volume in two other planes, and so these views get updated. Then we have the zoom interaction, which means that we are looking at some region of this slice, and we might, by zooming in, we make that region smaller and smaller, which actually blows up the image in this view. Okay? We're blowing up the image. And whenever you're zooming in the image, you can always see this little box in a corner that shows you what portion of the image you're seeing. And in addition to zooming, there's panning, which is just basically keeping the zoom the same, but moving around the zoom box relative to the slice. So the four operations were out of plane, cursor changing, in plane, cursor changing, zooming, and panning. Now, while we're on the topic of zooming and panning, there are two ways in which zooming and panning can be changed. One mode is when each slice view, each one of these three slice views, has its own zoom factor. That's what we're seeing here. So we really zoomed in on this image, but these images are still being viewed at their original zoom. Sometimes that's useful. Sometimes we prefer to maintain the same zoom level in all three slice views. And we call that linked zoom. And so here, if we go to the zoom inspector, we can turn on linked zoom, and then we'll have the same zoom factor in all slice views. And the way in which we measure zoom is in screen pixels per millimeter. And that kind of makes sense. So what that really means is how many pixels on your actual display correspond to 1 millimeter of physical space. So if your image is a typical MRI image, your voxel size might be 0.9 millimeters or maybe 1.1 millimeters. But the way to represent zoom is always relative to the number of screen pixels per unit of physical distance. And that just works consistently no matter what your voxel size in your images is. Okay, so how to use these navigation tools. We use the mouse. I know most of us don't have mice anymore, but really it's a good $10 investment if you're going to be using Snap a lot, because it's a lot easier to paint with a mouse than to paint with touch screen. So with the mouse, the left button is used for in-plane cursor motion, and the mouse wheel is used for out-of-plane motion. And in order to modify this 3D cursor or crosshair, we have to select the crosshair tool on the main toolbar at the top left. If we want to zoom and pan, we select the zoom tool, and then the left button is going to pan and the right button is going to zoom. But also the right button zooms almost in any navigation mode. So even the crosshairs tool, you can still use the right mouse to zoom. So pretty consistently, the right button can be used for zooming. So let me do a little quick demo of this stuff. So by the way, you can see that now that I've loaded a couple images in ITK-SNAP on my computer, the way it starts up is a little different. Before it would start up with this kind of welcome screen. Now it takes me to the recent images view. So I can just click here one of my recently viewed images. So let's say I click this one. So right now I'm using my mouse wheel, or I can also use this slider. And you can see I'm moving in the top left view, I'm moving in and out of plane. So I'm going from the most inferior part of the brain up to the most superior part of the brain. Using my left button, I'm now keeping the slice the same, but I'm moving in the slice, and that changes my other two views. So using this kind of navigation mode, I can very quickly find the structure that I want. Let's say I want to find the hippocampus, because that's my favorite structure. So with a couple clicks, I was able to find it. So here, now my cursor is pointing at the hippocampus, and I'm seeing in all three of my slice views, I'm seeing the hippocampus. That's sort of the power of this linked three-dimensional cursor, is that once I place the cursor in the structure, I see the three coronal, axial, and sagittal aspects of that structure in all three slice views. This is not a very high-res image. Maybe I should, let me go to another image. Let's go to this mouse image. Maybe it's a little better. So here, again, I clicked. This is the mouse hippocampus. Somewhere here. And I can look at it. Just back to my demo. So here, again, I can sort of click and find my hippocampus. And now if I want to zoom in on it, I choose my zoom tool, and I use my right mouse button to zoom in. And here on the left, there are a couple useful commands like center and cursor. It's just going to automatically pan for me so that the cursor is in the center of my view. I can also pan like this, or I can pick up the little white box here and I can pan this way. So most of these common ways of interacting with the image can be accessed in multiple ways. The keyboard also works, so I can navigate my cursor using arrow keys on the keyboard. So there are many little tricks to perform navigation. And then I can also set my zoom factor. I can zoom to fit, which fits all three of my slice views, or I can set a specific zoom factor, or I can do this 1x, 2x, 4x kind of zooming, where one of my screen pixels is going to correspond to one of the MRI pixels, more or less. That only works if your pixels are isotropic, if your voxels are isotropic. Okay, so let me just say a word about what I mean by contrast. So contrast basically describes to the difference in brightness between different tissue types in the image. And if we look at the image on the left, we can barely tell apart the white matter and the gray matter because it has poor contrast. The image on the right, the gray matter and white matter are much better to tell. Now, the image behind you has much better contrast than either one of these two. And so the contrast is something, when we're doing segmentation, we really want to maximize the contrast between whatever it is that we're segmenting and whatever it is that's around it, because that's what guides our segmentation. And the way we adjust contrast in ITK-SNAP is using a dialog. This is called a layer inspector dialog, but it includes contrast adjustment. So let's just go through this dialog really quickly. It has a left pane which lists all of the loaded anatomical layers. In this case, we only have one image loaded, this main image, so there's just one image shown on the left. If you had additional overlays, you'd see those overlays shown on the left as well. At the top of the contrast adjustment panel is what we call simple or linear adjustment, and this basically allows us to specify what is the range of image intensity that is mapped onto the visible range of display intensities. So our display can show us intensities from black to white, going through different shades of gray. And this is saying, that we want 0 intensity in the image to map to black, and intensity 1580 to map to white, and all the intensities in between are linearly mapped between these two values. So in this particular image, we can see that the range of the intensity is actually from 0 to 2600. But in this particular case, if we look at this image histogram, we see that there are very few intensities over 1,000, very few voxels that have intensity over 1,000. So instead of mapping 0 to the maximum value in the image onto this different shades of gray, we're actually going to map from 0 just to 1580 onto the black to white range here. And so all the voxels above 1580 are going to have the same visual appearance as 1580. They're going to look white in this case. But by doing this, we improve the contrast for sort of the interesting range of the image. So we have this simple linear adjustment. Sometimes we want to go a little bit beyond that. Instead of having this kind of linear mapping from the range of image intensities to the different shades of gray, we might get a curvilinear mapping. And that's what the controls down here allow you to do. You can actually turn this linear map into a curve. And you also can just view the intensity histogram of the image within this window. So going back to the simple contrast adjustment, this is just a representation of this mapping between raw image intensity and visual grayscale level, and it's a flat function, and it has a linear portion and again a flat function. So everything below minimum maps to black or 0. Between minimum and maximum, you linearly go from 0 to 255, black to white, and everything above the maximum intensity gets mapped to white. You can also, in some software, we refer to this as level and window. So level is sort of the middle between min and max, and window is the difference between min and max. So basically, the range of intensities that you're viewing. And in ITK-SNAP, you can specify level and window or min and max as you want. So here's an example for an image. So here the level is 800, window is 600, which corresponds to minimum 500, maximum 1100. And you can see that, for example, here we have intensity 1300, which is above the maximum value, and so it's displayed in pure white. Here we have intensity 400, which is below the minimum of 500. It's displayed as pure black. And then we have intensity 800, somewhere here in the white matter, which maps to some grayscale value. So in addition, we could do nonlinear contrast adjustment, as I mentioned. So here's a linear, and here's a nonlinear setting of contrast within the same image. And we can also change color maps. So instead of just mapping our intensities into a range from black to white, we can map our range of intensities into different color hues, or going from sort of black to red to yellow, or this copper color map. We have about a dozen different color maps, or a little more than a dozen different color maps that are built in that you can select in order to visualize your images. So if you're working with statistical maps, this kind of hot display is useful. MATLAB defaults to this jet color map, and so sometimes that gives you the most sort of, our eye is better at distinguishing colors than just shades of gray. So sometimes it's just useful to use these color maps for visualization. So on the same dialog, there's another tab called Color Map, where you can select one of these presets, color map presets, or you can design your own color map. So let me go on to working with segmentations. So we already seen this slide, but just to remind ourselves, segmentation again is about assigning numerical labels to voxels. The background labels always have label 0, but every foreground structure that we segment, every structure of interest, is going to be assigned a different numerical label. So sometimes we already have a segmentation to start with, so maybe somebody shared a segmentation they did with us and we want to view it. So one thing important to know is how do we open a segmentation. And there's a similar kind of dialog that we used to open the main image. There's in the menu an option to open a segmentation image, and you're going to do this in your exercise. Inconveniently, there's a history here, and at the top part of the history will actually tell you what are the segmentation images that you have loaded for the main image that you're working with. So you don't have to search through your file system. If you've loaded joesmith.nifty as your MRI image, it'll show you, well, this is the segmentation for that image that you last did. Now, of course, we should never name our images joesmith.nifty. So viewing segmentations, a couple things about viewing segmentations. Once we've loaded a segmentation, what we'll see is that the different labels in the segmentation are overlaid on top of our main image using different color. And by default, there's some transparency, so you can kind of still see the image structure sort of through these green and red labels. You can also generate a three-dimensional rendering of this segmentation just by clicking the Update button at the bottom left of this three-dimensional window. So useful thing is when your cursor is clicking at a voxel that has a segmentation, you can see here in the cursor inspector, it'll tell you what is the numerical value of the label under the cursor, in this case 2, and what is the description. In this case, the description is active tumor. And then, like I mentioned, there's this 3D surface representation of the segmentation. If we change to the label inspector, so we click this little paintbrush down here, in the label inspector, a couple of other useful controls. There's the opacity control, which changes how transparent these labels are. So we can make them completely opaque. And there is a button to bring up a label editor, which is going to allow us to view the different labels that we're working with and also change their names or create new labels, etc. And this is the dialog that will come up, and in the next session you're going to start out with an exercise that uses this dialog to create a bunch of labels. And there you can select the color for the label, change the opacity for that specific label, and there's also, this is new in version 3, a little search box. So if you're working with segmentation where there's 1,000 labels, you can actually find them before you had to actually scroll through this 1,000 labels, which is incredibly painful. And you can also save and load label sets. So whenever you create this kind of set of labels or a label description file, you can save it, share it, and load it again. And finally, once you have a segmentation, it's always very important to get some information about it, and volume is sort of the one measure everybody's always interested in. And there is a volumes and statistics option under the menu that allows us to see the volume corresponding to each label in your segmentation, as well as some intensity statistics for each label. So in this case, this is showing the mean intensity and the standard deviation of the intensity for each of these labels in a particular image. If you have multiple image layers loaded, it will tell you the mean intensity for each loaded image. So in this case, you can see that the mean intensity of the edema is very low, much lower compared to the mean intensity of the active tumor. And you can export this to Excel. Let's just do a little quick demo. Okay, so here's MRI scan, and I'll just take you through some contrast adjustments. So we can bring up, the contrast adjustment can be brought up through the Tools menu, Image Contrast Adjustment here. There's also this little icon over here that does the same thing. I'll click that. Or Control-I on Windows, Command-I on the Mac does the same thing. So here's my contrast adjustment stuff, and I could type in the values here, but I can also just move this top control point, and that does the same thing. So I can just drag this top control point and see I'm doing a linear contrast adjustment on my image. If I want to do non-linear, I move one of these middle control points, and it lets me create kind of a curvilinear contrast adjustment. If I need more detail, I can create control points, additional control points, and get really fancy looking intensity remapping. Although I just managed to completely get rid of contrast in my image by doing this. There's a reset button, and there's this auto button, which is quite useful, which also corresponds to the Control J on your keyboard. And that automatically analyzes the histogram of the image and sets the minimum and maximum based on the image histogram. And that's really, for 90% of the images, just hitting Control J is good enough. Here we have a color map. So instead of using the default grayscale color map, I can change to jet or hot or whatever else I feel like. Also in this dialog is some information about the image, basic information about dimensions, voxel size, orientation, the position of the cursor, and there's some metadata which is kind of specific to the file format. If this was DICOM, you'd see lots and lots and lots of information here. And also, this is also searchable. And let's do something that has a segmentation. I'm going to go to my recent images list and pick out this Bratz tumor data set, hit Control J, Command J on my Mac to adjust contrast. I guess it's already, where is it? Okay, I've adjusted my contrast. Now I'm going to go with segmentation, open segmentation. That brings me up this dialog. I hit browse, and there I have a segmentation of this image. Next, finish, and so here I'm showing the segmentation. As I showed in the slides, here in the cursor inspector, I can see what is the label under the cursor. I click here in the background, it tells me 0, clear label. I click on the edema in the red, it tells me 1. Oh, label 1. Click here, it says 2, label 2. So right now my label descriptions haven't been set yet. So let me see if I can import label descriptions. Oh, I don't have them. Okay, so I'll have to make my own label descriptions. So I'm going to go over here, label inspector, label editor, and now I can rename them. Edema. Oops. I think I lost my keyboard. I don't know how, but I lost my keyboard. So I can't type. So pretend that I typed something here. It had nothing to do with Snap, though. That was a Keynote bug. I can also change the opacity here. So make them completely opaque or semi-transparent. And volumes and statistics are also on their segmentation menu. Here I can view the volumes of these different labels. All right, so that's it for my little demo, and I'm gonna go ahead. Let's go ahead and do this exercise 3A in your handout, which basically has you do what I was doing in the last couple of demos.